Hey everyone, welcome to the first video in an epic 3-part series where we are building a super cool RAG demo. And here is the kicker. We are doing it all without writing a single line of backend code. Today we are kicking things off with n8n and Qdrant to create an AI-powered document retrieval system. Imagine dragging and dropping your way to a smart backend. It's that easy with n8n's visual nodes. By the end of this video, you will have a system ready to store and query documents with AI magic. Let's dive into this no-code adventure. Okay, quick question. What is RAG? Retrieval Augmented Generation or RAG is like giving your AI a photographic memory. It uses a vector database to retrieve relevant info and a language model to generate answers based on that retrieved information. Think of it as a super smart librarian who finds exactly what you need and explains it perfectly. And today we are building it without touching backend code. Pretty wild, right? All the codes that I am using, you will be able to see the repo link in the description below, so please use that. Once you clone the repository, if you do ls, you will be able to see this particular item n8n RAG. So this is the directory that we will be working on today. So if you look at the directory structure of that n8n RAG folder, you see it is a very simple directory with very few files available. Inside this n8n RAG folder, you will see one v1 folder which corresponds to project that we will be using for today's video. This is the first part of a 3-part series. In this one, you can see one docker compose.yaml file. We only have this docker compose.yaml file for us to start working with n8n and Qdrant. Okay, and there is also one nodes folder which will contain the instructions on what are the commands that you can execute in order to run this particular application. Let's look at the project code. Here, as you can see, you will be seeing this TechieTalks AI once you clone. Inside the TechieTalks AI repository, once you clone, you will see this n8n-RAG folder, and there you will be seeing this v1 folder. And this v1 folder contains the docker compose.yaml file which we will be using. And it also contains one env file. So this env file can be used to provide the environment variables that we want to provide to our Docker containers. And I created one env.example to give you an idea of what are the envs that we should provide. And finally, you will also see the nodes.txt which will contain the instructions. But we are interested mainly in this docker compose.yml file. Let's get our tools running. We are using Docker Compose to spin up n8n and Qdrant in one go. Here is the docker compose.yml file. Super simple, just a few lines to define our services. Let's understand this docker compose.yaml file. First, we are starting with a couple of volumes. So these volumes we will be using for persistent storage. This will allow us to spring up these n8n servers at any time and to have the previous data available, so you don't have to set it up from fresh each and every time. So we are creating two volumes. One is n8n_demo_ storage, like the name suggests. We will be using this for n8n, and we also have another volume which is Qdrant demo storage, which will be used for our Qdrant application. Now after that, we are setting one network. So we are giving the network name as a demo. So we want to ensure that both n8n and Qdrant are running on the same network so that they will be able to talk to each other without any issue. Here we are specifying a placeholder in Docker Compose. So this is the syntax that we will use. So this is the key for that particular placeholder, and this is how you will be able to define it as a placeholder and add a tag to it. So wherever we want these items to be used, we will be able to refer to it using the service -n8n name or the tag. So that is the advantage of using this. And here we are specifying the image as the n8n official image, the Docker image, and we are specifying the network to be the one that we created in this particular section, which is AI demo. And we are also setting some environment variables for our n8n server to use. Okay, and along with this n8n server configuration, we are also adding one configuration for the Ollama host. So we will be accessing the Ollama host that is running within the same machine using the internal Docker host. You can also run Ollama as a service using the Docker Compose itself. If you want to access that Ollama running as a Docker Compose service, this is how you will be able to access it using Ollama, which will be the service name followed by the port. Now let's go to the core services. So here, as you can see, there are two services that we are creating. One is named as n8n-auto and another one is named as Qdrant. So let's first look at the n8n-auto service and see this. This is how you will be able to refer to this particular placeholder section that we created earlier. So all the content that we added within that particular placeholder section will be replacing this particular line. So this is a very good way for us to create Docker Compose files which reuses same lines of codes at multiple places. And here we are specifying the host name to be used for this service, which is n8n-auto. So this is the host name using which you will be able to address this particular service. And we are also using the same as the container name, and we are specifying the restart policy as unless stopped, and then we are also configuring port mapping with port 5678. And here this is where we are mounting the volume that we created inside the service container. So here we are making use of this particular volume that we created using Docker Compose, and it will refer to the n8n home directory. So all the n8n configurations and all our n8n work will be stored within that particular storage volume. Now this is the n8n service. Next comes the Qdrant service. Now here in this Qdrant service, we are using the official Qdrant image from Docker Hub, and we are specifying the host name and container name as Qdrant. Like in the case of n8n, we are also specifying the network as AI demo, which is the network that we created in here. And we are also specifying the restart policy and the port. So for Qdrant, we will be using the port 6333, that is a default port of Qdrant. So we will be using the same. And here we are setting the volume mapping for our Qdrant. So Qdrant storage, we are mapping it to the Qdrant demo storage volume so that it will persist the data even after we terminate the container. And finally, we are setting the environment variable to be used for the Qdrant. So Qdrant service enable dashboard. So this will ensure that we have a dashboard access to our Qdrant service. So you will be able to visually interact with our Qdrant service if you have this enabled. So that's it. This is a very simple code, very simple Docker Compose YAML with just two services, which is n8n and Qdrant. Now let's open our terminal, cd into our n8n-rag folder, and inside that we have to cd into the v1 folder. So once you are there, you will see the Docker Compose YAML file which is ready to build. So now let's run and build this. So we will execute the Docker Compose up-d command to build and run this. So it may take some time for it to download the image and create it. So since I already downloaded the image, it is using the image from the cache. So that is why in my case the creation completed very fast. So in order to verify this, let's execute the Docker Compose PS. As you can see, both the containers or both the services are currently running. Now it's time to access our n8n application and do the initial configuration. So in order to do that, let's open our browser and browse localhost colon 5678. So this will spring up our n8n server. First time you will have to set up your n8n server. So it is a one-time setup because we are mapping the volume. So once you do this, from next time onwards you will be able to just log in. You can just provide your information. So I'll skip to the end of the configuration. So just follow the instructions on the screen so that you will be able to complete the setup. It is pretty straightforward. So once you provide an email and a password along with your name, you will be taken to the welcome page. So this is the welcome page of n8n. So welcome to n8n. Remember, if it's your first time, you will set up an admin user, which takes around 2 seconds. Check out this interface, visual notes everywhere. This is where we'll build our workflows without writing a code. It's like playing with Lego for AI systems. Now that we have access to our n8n server, let's take a peek at Qdrant 2. So in order to access Qdrant, we can browse localhost colon 6333. So this will take you to the Qdrant. So here this is telling us the Qdrant versions. So in order to access the dashboard, you will be able to browse dashboard. So now this is the Qdrant dashboard, clean and simple. Soon it will be filled with document vectors, but for now it's ready and waiting for our magic touch. And here on the left side you will be able to see the different options. So here if you click on collections, you will be able to see the collections that are present. In our case it is empty now, but we will be filling it up soon. So here I am going to use this particular dataset, which is Wonders of World from Karnika Kapoor. So I am going to download this from Kaggle and I will be using this data. So let me just download this. So I will download it as zip file. Okay, it's ready. So this is the downloaded data files. So there are multiple dataset CSV files. So I will be using this particular CSV file. So it is a very short dataset, but for our demo purpose this will be sufficient. So this contains names of different wonders of the world, the type of the wonder. Then we will see the latitude and longitude along with the location. We also see the Wikipedia and the picture link for that particular world wonder. And we'll also see the year in which it was built. So let's make use of this one. So this is the one that we will be using. Now, like I told you, we will not be using any code in order to perform this operation. We want to do it with the help of n8n. So time for the fun part, our first workflow. We are building one to upload documents via chat, turn them into vectors and store them in Qdrant. Before we start with creating our workflow, we need to create the credentials so that our n8n can access the Ollama that is running within the same machine. So first let's go to the credentials tab and let's click on add first credential. And here you can search for Ollama and then click continue. And here instead of localhost we will be using the Docker based URL, which is our host.docker.internal with the port as 11434. So let's save this one. So you should get one message saying that the connection tested successfully. So this means that our n8n is able to connect to the Ollama that is running within the same machine. So that's the first credential that you need to create, which is the Ollama account credential. Now the next credential we need to create is for our n8n to access our Qdrant server. So in order to do that, we have to create another credential. You can click here and click create credential and you can search for Qdrant API credential. So just click continue and here you can keep the API key as empty, and in the Qdrant URL you can give http:// our service name, which is Qdrant : then 6333. So this is the port and you can click save, and here also you should get connection tested successfully message if the connection is successful. If n8n is able to connect to our Qdrant server that is running. Now that's it for the credentials part. Now that the credentials are ready, let's start by creating our first workflow. Now it's time for the fun part, our first workflow. We are building one to upload documents via chat, turn them into vectors and store them in Qdrant server. So in order to do that, let's start by creating a workflow, and for each workflow there will be a first step which will be the trigger. So let's start by adding a chat trigger node. So you can click on this add first step, and these are the different triggers that are available, and here we are interested in this particular trigger which is on chat message. So this is the chat trigger. So when someone sends a message, this particular workflow will be triggered. So let's click this, and that's it. Yes, it's that easy to add a new trigger. Now you will be able to save this workflow. If you want to save this workflow, you can just click on this particular name and you will be able to give any name. So I'm going to give this add rag option, and then you can click save. So now our workflow is saved, but our workflow is not yet complete. So we added one trigger node, which is when a chat message is received, this particular workflow will be triggered. Now we have to add the functionality. What should happen when it receives a message? So let's try this chat option. You can click open chat, and here you see there is only option to send message. So it doesn't have the option to upload any file. So we need to enable that first. So let's close this, and here let's double click this to configure it, and here under the parameter section click on add field, and there you will see the option allow file uploads. So this is the first thing that you have to do in order for us to be able to upload our file to be added to the vector store. So you have to enable this option, and once that option is added, make sure to enable it. So now this chat will allow file upload. So let's click outside, and now let's save it. And now if you click open chat, you will see this attachment button. So using this you will be able to now attach any files to our chat. Okay, now it's time to add the functionality, which is what happens when the user attaches a file in the chat. Here we want it to add it to the vector store, and it is very simple in n8n to enable that option. So let's click plus option to add a new node, and here let's search for Qdrant vector store. So this is the node using which you will be able to upload a dataset to the Qdrant vector store. So let's select this option, and here you see the option add documents to vector store. So we have to select this second action for that Qdrant vector store. So let's click that, and it will add the node. And here you have to select and give the Qdrant API credential that you created, and operation mode, make sure that it is insert document, and collection, that is the name for the collection, you can select by ID, and here you will be able to give any ID. So I am going to add, say, wonders of world. Okay, so this is the ID. Let me just give it full lowercase. It is not mandatory, you can give full uppercase also, but I want it to use this particular collection name, which is wonders of world. Okay, so that is the Qdrant part. Now for this Qdrant vector store to embed the document, you need to provide two items. One is the embedding model and also the document to embed. So let's click on this embed model, which is to add an embedding. So since we are using Ollama, we will be able to select this final option, which is embeddings Ollama. So let's select this option, and here we have to select the Ollama credential that we have created, and from the model we can select our Ollama's embedding model, which is this nomic embed text latest. So now this is the embedding model which this Qdrant vector store will be using. And in order to go back to the Qdrant configuration, you can click on this particular section, and now you will see that the embedding is already added. So the next step is to add the document, the source document to embed. So there, if you click plus, you will be able to see the option as default data loader. So this is the one that we need to use so that we can load the data from previous step within the workflow. So let's select this particular option, default data loader, and here in the type of data you have to select binary because we will be uploading the binary, and you can select the mode as load all input data, so we'll keep it as it is, and you can also specify the data format for it to automatically detect by the MIME type. And here one more configuration is required, which is the text splitter. So if you click on this text splitter, you will be able to specify how you want the text to be splitted and added to the vector store, and here we will be able to specify recursive character text splitter because this is the one that is useful for most use cases. This will be much more meaningful. So let's use this option, which is recursive character text splitter, and we will be able to specify the chunk size. Let's specify the chunk size as 500 and chunk overlap as say 50, so that we will be having a good chunk size and good chunk overlap. You can even reduce the chunk size since our data is small. You can even reduce it to say 250, so that also will work. And chunk overlap, we can make it say 25. Okay, so now let's go back to the data loader. So data loader, you will see this text splitter is now connected to it, so that part is done. And if you go to the Qdrant store, both embeddings and documents are added. So that's it. So now this is our current workflow. So this is our full workflow. You see the trigger, which is when a chat message is received, and when the chat message is received, it will trigger the Qdrant vector store, which will be performing the embedding using the Ollama embedding that we have added, and then we'll be using one default data loader, load the data that we are attaching to our chat, and it will be split using the text splitter that we have configured. Now our workflow is ready. Let's save this one. So the workflow is saved. Next, it's time to test it. Let's test it out. I'll upload a sample, the one that we downloaded previously, which is the Wonders of the World. So I'll be using that. We'll trigger it via the chat and we'll see how n8n processes it. Let's click on this open chat, and here I'm going to attach my file. As you can see, I attached the Wonders of World Rev 3, and I'll just message something, hi, and then I'll send this. So now see this, it is getting processed. So Qdrant vector store is processing. It got the data and it created the embedding from that data. And see this, the processing is complete. So it split the data into different tokens, and then it performed the embedding operation. Now let's jump to the Qdrant dashboard and let's refresh this, and here is our collection full of vectors. We just built that without a single line of code. How cool is that? And here you will be able to go for different visualization. Like if you want to visualize this, you can just run this option and you will be able to see the data visualization. See the different options. On the right side you will be able to see the content for those items. So we just created this particular collection using n8n without any coding. Now we have our workflow to upload the document to the Qdrant vector store. The next part will be to see how you can query that vector store, because without being able to query, it is of no use, right? So let's make a basic query workflow. So we'll create a new workflow within n8n. So let's go back to n8n and we'll come back to the home page, and here we'll click create workflow to create another workflow. And here also we will be using the chat trigger. So let's select on chat message, and here we don't need any file upload capability, so we'll use it as it is. Now let me just save this. I'm going to give the name as say RAG query, and I'll save this. Now we added the trigger. Next we need to add what should happen when the user sends a message. So we want it to query the vector store and give a response. So there are multiple ways using which you can do that, even using an AI agent. So in the next video we'll be seeing how we can perform that operation using multiple nodes. So we'll see the different ways using which we'll be able to query the data within the Qdrant data store. But let me just show you a very simple way of doing that in this particular video. So here we'll be going for one question and answer chain. So just search for question and answer chain, and here this is the node that we'll be using. So here you can see it is connected to the chat trigger. It will be using the chat input. Now in this particular node we can connect two options. One is the model and another one is the retriever. Model is used to specify the large language model using which the final output will be composed. So let's click this add model option to add a model. Like in the last workflow we will be using Ollama. So we will be using Ollama chat model, and make sure to select the Ollama credential that you created earlier, and here under model we will select Llama 3.2 latest. So this is the model that we wanted to use while generating the response. Now let's go back to the question and answer chain node, and let's add the retriever. Before that you will see the model is now connected. Now let's add the retriever, and here we want to retrieve data from a vector store. So we will use this vector store retriever option. So we will select this option, and here we will be able to specify the limit number of response that you want it to be retrieving from the vector store. You will also see the option to connect a vector store. So this is how we will be able to connect this vector store retriever with our Qdrant vector store. So let's do that. So we will click add vector store, and here from the options we will select Qdrant vector store. So let's select that, and here we will be selecting the operation mode as this one, which is retrieve documents as vector store for chain or tool, and we will also have to specify the Qdrant API account, which is a credential that we added for Qdrant, and then we will be able to select our collection name from the list, which is Wonders of World. So if you want you can also specify by ID and type it, but here we can just use the list to select from a drop down. In this node you will also see the option to add an embedding. So remember, when it comes to vector store, for adding to the vector store and retrieving from the vector store we need to create an embedding. So the embedding that we will create at the time of querying will be known as the query embedding. So we need to connect an embedding model to this Qdrant vector store query. So let's click on this add embedding. We will again use our embeddings Ollama. So we will be selecting this embeddings Ollama section, and make sure to have the proper credential selected, and we will select the Nomic embed text latest model embedding model for this one. So if you go back to the vector store, you can see embedding is now connected, and if you go to the vector store retriever, our vector store is connected, and if you go back to the question and answer chain, both model and retriever is now connected. So this is our workflow. So let's save this. See, this is our workflow now. Here you can see everything starts when user sends a chat message, then it will call this question and answer chain, which will be retrieving the data from vector store using the vector store retriever, it is connected to our Qdrant vector store, and we have enabled Ollama embeddings for the query embedding. Finally, the response will be generated based on the output received from the Qdrant vector store querying, and it will be generated by this LLM model, and we will get the response. So let me just save this workflow. Now that's it. It's all drag and drop, no code needed. It's time to ask something. Let's test it. Now to test, let's open the chat, and here you have the option to send the request. So it's time to ask something. How about where is Stonehenge? So now what is happening is it is querying the vector store, and vector store retrieved the correct relevant information. Now the LLM is generating the response based on that particular query response. So first time it will take some time for it to generate, and voila, see this, it is giving the proper response, which is Stonehenge is located in Amesbury, United Kingdom. Okay, so here you can see what are the steps it did. So when we send a chat message, it went to this question and answer chain, which in turn called the vector store retriever with this particular input, and it got this response back from the vector store retriever. See this one, and it used this Qdrant vector store to retrieve it with this input, and here this is the output. See this is the output that it retrieved. And if you look at the embeddings, you will be able to see the query embedding. So using this query embedding, the Qdrant vector store retrieve this particular output, and this output is given to the Ollama chat model. See this, it is saying this is the system information, use the following pieces of context to answer the user's query. If you don't know the answer, just say that you don't know. And here this is the context and all the data related to Stonehenge and other information it gave, and there based on that the LLM generated this final response, which we are seeing as response to our query. There it is. We have just built a RAG backend without any backend coding. But trust me, this is just the warm-up. Next time we are cranking it up with 3 mind-blowing ways to retrieve data from Qdrant just using n8n's visual nodes. From simple Q&A to AI agents that remember everything. It's going to be epic, and still no code. Hit that subscribe button and stay tuned. You won't believe what's coming. So see you in the next video. Bye bye. Thank you.